Hey everybody. Today I wanted to tell you a little bit about factoring. This is covered very clearly in Chapter 1, Section 5. Still kind of in the review section here. You should have seen this somewhere, but this is one of those things that kind of comes back to bite people. So it's a little reminder here, and hopefully it'll remind you of some tricks. Um, First thing that I have here is to kind of show you what we're doing here. Last couple lectures, we've kind of talked about the FOIL method and how you can use that to multiply two binomials. So right here, I have x plus 2 and x plus 3. Those are multiplied. Remember that we're effectively distributing everything in the first one times everything in the second one. And with the FOIL method, that turns out to FOIL. The first times the first, that would be x times x, which is x squared. And then I need to do outer O, which would be the outer times the outer, the first one times the last one here. And that would be 3 times x. And then I can do the inner times the inner. So that would be 2 times x would be another 2x right there. And lastly, I've got the last times the last. 2 times 3, positive 2 times positive 3. It's going to be positive 6. We want to combine those like terms right there. I end up with x squared plus 5x plus 6. Okay, so that's what happens when we multiply those two binomials. Factoring goes and takes that back apart. We want to separate it back out. So if I had this over here and I want to get back to the x plus 2x plus 3, that's what factoring is good for. And we usually start off by putting two sets of parentheses like this. And if you remember that FOIL method, I need something right here times something right here that's going to give me that first term, right? So first times first. Well, x times x would do that pretty nicely, wouldn't it? So we'll put that in. I like to go look at the last times the last next. I need some factors of 6. The only way I can multiply and get 6, of course, with integers anyway, would be 1 times 6 and 2 times 3. And this 5 right there tells me that I'm really trying to find something that will multiply to 6 and either add or subtract to 5. So when I take 1 times 6, that adds to 7, and it would subtract to 5. 2 times 3 multiplies to 6, but it would either add to 5 or subtract to 1 or negative 1, and depending on which way the signs were and stuff. So those are kind of my possibilities. And since we want a 5 in the middle, we could really do it with either one. And in the end, this kind of comes down to trial and error and just what you know about um, this. But the other thing I'd like to remind you to do is to watch the signs. So when I've got a plus sign right there, that tells me that when there's a plus sign there that I'm adding these two numbers. And remember how this one we got when we were subtracting over here? So it's not that 5, it's this 5 when we add them. I need to have the signs alike and positive. I probably could have said that a little bit better, but we'll do some more of these. The signs are the same. Let's put that. When this sign is positive, it means that the signs are the same. So I either have a plus and a plus in these two, or a negative and a negative right there. But I look at this first sign and it says they're both positive. If they're alike, then they're both positive. If this were a negative, then the bigger one would be positive. The second one would be negative with the way it is. So I need a 2 and a 3 here. And you can see that we're back to where we started from here. So that's the factorization. The tips and hints again, look at that last number. You need two numbers that multiply to give you the last number, and then they should either add or subtract to give you the middle number. And those signs tell you when these are alike, both positive or both negative, and when they're different. One could be a positive, one could be a negative. So that's kind of the trick of the whole thing. Let's try some more. Here's that little trick of watching the signs. And I'm going to rip through these. Bring these up in class if you have any trouble with these, and we'll work as many as you can stand. X squared, that's going to be x times x. My only factors of 2 are going to be 1 and 2. Right there it says the signs alike. And so I'm going to, they're both positive. So if I go ahead and put a plus and a plus, my factors again were 1 and 2. So if I put those x plus 1, x plus 2, never hurts to multiply this thing back and just make sure that it works. We'll do this one here so you know what I'm talking about. But x times x would be x squared. There's a 2x. Here's a 1x. And last times the last is going to give me a 2 right there. And you can see that's the x squared plus 3x that we started with, plus 2. And this is almost the same problem over here in the second column, but the signs are different. And so that's kind of what we want to look at here. Clearly need an x times an x to get that x squared. All right. My factors of 2 again are 1 and 2. Let's go ahead and put those down. I don't really have any other integer choices. Right here, when I multiply this 1 and this 2, I get a negative 2. So the only way that can happen is if one of them is positive and one is negative. And the question then becomes, well, which one's positive, which one's negative? I can look at this sign and, that last sign told me that they were different, one positive, one negative. This one says the big one is negative right there. And so the bigger number is 2. I'll put that here. And the other one is positive. You check it and you get an x squared minus 2x plus x minus 2. Positive 1 times negative 2 would be negative 2. And when you combine those like terms, then you get back where we started. The signs tell you which way to go on these things. Here's another one. And I got an X and an X. I got a 1 and a 2. The signs are different. And this time the big one is positive. Okay. Now, I should take care here to mention that if you had a negative X out front, the big one would be the product of, or even a number, right? Even if there were a 4 here or something. We don't have a 4 here, so we don't really have to worry about it here. But you're really taking that outer and the inner, and which one of those is bigger? Here it's a 1 out front, so it doesn't really matter, 1 and 1. But clearly I need a positive and a negative, and the big one should be positive. So when I do 2 times x, that's 2x. When I do 1 times x, that's 1x. And the 2x would be bigger, so I want to make sure that that is the positive one. If I get that like that and the other one negative, there's my 2x. Here's minus 1x, so I'm down to just 1x like the problem says. Last one on this page is x and x. I got a 1 and a 2. The signs are alike. So they're either both positive or both negative. If I made them both positive, then I'd have 2x and 1x, which would be positive 3x. And that's not what I have. So, you know, just kind of think about the way these go together. They're alike, and the big one or both of them have to be negative. Then just put negative signs there. I get on the outers and inners are what are going to get you here, right? So minus 2x, minus 1x, and that's going to give us negative 3x like we wanted all along. So there you go. Not too bad. Takes a little practice. Here's some problems that have common factors in them. Sometimes, don't know why I did that. Sometimes there is a number or a variable or a constant or something that we can pull out of each one. That makes the problem smaller and easier to work with. Now, yeah, we could come over here and say, this is probably 2x times 2x, and mess around with that. And, well, actually, I need an x squared, don't I? Okay. So, this one's a little convoluted and stuff, but watch how easy it becomes once we pull that common factor out. You should always, always, always look for the common factors. And by common factor, what I mean is I got 3 terms here. Is there any factor that's in all 3 of those? Well, I could divide all 3 of those by 4, So let's pull a 4 out front. I got three X's here, two X's here, and one X there. I could reach into each pile and pull out one X. Okay. So the question then, and that's an X, not a multiplication. Um, the question then is, what will be left behind? I need three things in here so that I can distribute 4X to each of these three things in here and get 4X cubed. Well, I got the 4X cubed. I need an X squared right there. All right. Check it out. 4X times X squared would give me 4X squared, cubed rather. I'm sorry. So that gets me back to where I was. I need something here to multiply by 4X to give me 12X squared. So I don't have the 3, and I need one more X like that. Multiply it back. 4 times 3 would be 12. X times X is X squared, and that's what I started with. Okay. And then in the last place here, it's already plus right there, so I don't need to worry about that. But I need something here times the 4X, that'll give me 12X. Clearly, I'm just missing the 3. So if I put that in, then 4X times 3 would be 12X. And you can see I'm back where I started from. Don't need this line anymore, and I'll get rid of some of this scribbling that I do all too much of. But you see how that took that weird problem and turned it into something that looks pretty familiar, except for the 4X sitting out front. All right. So what we can do is just ignore that 4X for a little bit. And let's come in here and see if we can factor this part that's in the middle there. Maybe we can, maybe we can't. I'm starting to worry about this one, actually. That might be as far as we can go with it, which would kind of be a weird problem, but whatever. Um, Only factors of 3 would be 1 and 3. So I pretty much got to put a 1 and a 3 here. They're both alike, right? Both of the signs in the middle of the binomials are alike, and they're both positive. Well, if I do that, you can see when I check my outers, I've got a 3X and a 1X, which would give me 4X. Okay, I needed 3X. So I can't factor it any farther. I've gone as far as I can. And sometimes, you can't go any farther. At some point, you can't break it open anymore. So on this one, I'd have to put my little box right here and say that's as good as it gets. I did factor out the 4X, which made things a little bit simpler. It's nice when we can go all the way down to simpler terms, but that's as far as that one's going. So we'll just leave that one right there. Stepping over here to the other one, I've got, looks like I could pull a 3 out of each constant term there. So let's get that. How many X's can I get there? 2 here. Let's just make an XX like that. This one has 1. This one has none. Okay. If I can't reach into every pile and pull the same number out, I can't do anything. So I can't pull any X's out. That's a disappointment. This one has a Z. This one has a Z. This one has a Z. So everybody's got a Z. I can park a Z out front. How about that? I got a Y and a Y and a Y. So I could pull a Y out front as well. Now I need something in here. This first term should multiply by 3zy to give me 3x squared cy. The part that I'm missing is the x squared, so we'll put that here. Next up, I want the second term. It's going to be positive, but I need something times 3 to give me 15. That would be a 5. I need something times zy, which gives me xzy. So I need an x there. And then in the last place, it's positive as well. So we'll put that here. I need something times 3 to give me 18. That's going to be a 6. And zy. I've already got all the variables. So we're down to here. And it may be possible to factor that stuff inside the trinomial there. Let's try an x times an x and a 2 and a 3. And the signs are alike. And they're both positive. So that would be plus 2 plus 3. Sure enough, that breaks down. And so that's one step farther than we were able to take that last time. Sometimes you get lucky, sometimes you don't, but knowing when to stop is important, right? Art is knowing when to stop. Now, what if there's a number out in front? Here's a little trick on these. With these, I would first look and see if there's a common factor. Okay. I got a 2 here. I do not have a factor of 2. There's no numbers that multiply by 2 and get 15 or 7 for that matter. So I'm not going to be able to pull any constants out. So now, and we're going back to the FOIL method. I need something in first place times something in first place that gives me 2x squared. Only game in town is 2x and x. Okay. This one's kind of lopsided, right? Because he got a 2 and the other one didn't. That's okay. I need some numbers that multiply to 7. So my choices are 1 and 7. 7 is a prime number. There are no other numbers that multiply to that, not integers. So the question is, should I put 1 here and 7 in the back, or should I do it the other way? And what we're doing is we're trying to make it add up to 15x. The signs are alike, and they're both positive. So let's put those in. If I put the 7 here, I'm just kind of trying to seeing what happens. But now 2x times x is 2x squared. So the first times the first and the last times the last is good. It's those cross products. It's the cross terms. When I do the outer times the outer, I get 2x plus 7x. Well, that's only 9x. I needed 15x. So that's not the right factorization. It was worth a try. And, there's only so many options. You're just going to go through these until you hit the right one. But with a little bit of experience, you go, oh, I see where this one's going. If I come and do it the other way, I would have my 7 here and my 1 there. And when I check the outer and the inner, I would get 2 times x, 2x times 7 would be 14x. Adding the inner times the inner would be uh, x. So there's 15x. That's the one that I needed. That would be the proper factorization of that one. If you have a number out front that you can't, pull a common factor out of everything, you got to do something like that. And it's a little bit lopsided and it makes it a little more cumbersome, but that's just life, right? Here's one right here. Looking for common factors. 15 could be 1 times 15. It could be 3 times 5. That's pretty much my only choices. Back here on the 24, I got 1 times 24 and 2 times 12 and 3 times 8 and 4 times 6, right? 24 is kind of a neat number because it has so many factorizations on it. But I need something, a pair of these and a pair of those. Clearly, I've got an x squared. Let's go ahead and put an x and an x. But I've got 2 choices here on the first number. It could be 1 and 15, could be 3 and 5. I got 4 in the back. Okay. I like to start in the middle. More often than not, it's in the middle. And if you look at this coefficient right here and it's a small number, head for the middle. If it's a big, big, big number, start on the other end. All right. But usually I'd start in the middle. So let's go with a 3x and a 5x and see where that takes us. How about the signs? The signs are going to be different this time. One's positive, one's negative, and the big one is going to be negative. All right. So that's where we're headed with this thing right here. And I would come in here and, if we try that 4 and 6 first, sometimes you get lucky. Sometimes it takes some poking around and stuff. If I put the 6 and the 4, when I'm looking for the big one to make it negative, I've got 3x times 4, that's 12, and 6 times 5 is 30. They're opposite signs, so I'm really subtracting. 12 minus 30 would be 18, and that's not what I need, okay? If I put the sign the other place, I'd still have an 18. It's either going to be positive or negative. So my 4 and 6 doesn't work this way. Does it work the other way? If I put the 4 here and the 6 here, That would give me 18 and 20. Opposite signs, I'm subtracting 18 and 20. 18 minus 20 would be -2, and that's the one that I want right there. So those numbers work. I do have to figure out where the positive, where the negative goes. But again, I'm doing, here's a 3x times 6, which would be 18x. And here's a 4 times 5x, which would be 20x. I need this guy to be negative so that my answer comes up negative there, and the other one positive. So what do I got to do to make that 3x times x positive? Positive times a positive would make that one positive, and a negative times a positive would make this one negative. And that one's a pretty good workout right there. But let's check it to make sure. Come on. I got all kind of mess up here. But you get the idea, right? You can do these, and we're just really doing the FOIL method in reverse. So 3x times 5x is 15x squared. Outer times the outer is going to be 18x. Inner times the inner, -4 times 5x is -20x. And the last times the last is going to be -24. Those middle terms are going to give me -2x, and that's what I wanted. So we're good. Okay. Um, Play with it till you get it right. Now, some of these have perfect squares in them. So right here, this one has there's nothing I can pull out of every term. I always look there first, especially if there's numbers and a coefficient out in front of this one and stuff. But I can't pull anything here. But I do know that 25 is really 5 squared and 4 is 2 squared. So I'm kind of watching that list of perfect squares that we put up a while back. And I'm going, wonder if I could do this where the square root of 25x squared is 5x, and I put that on both first, and the square root of 4 is 2, and I've got that. I notice that the signs are alike and that they're both positive. So that would look like this. I'm going to check it real quick here. First times the first is 25x squared. The outer times the outer will be 10x. Inner times the inner is another 10x to give me 20 x, which is what I wanted. And then the 2 times the 2 last times the last is going to be 4. That works perfect. Okay. So that's a perfectly good thing. Watch for perfect squares. When you see them, like in this problem right here, it's a pretty good bet that you got a 5x and a 5x for the first times the first, and a 4 times a 4 for the last times the last. And then all you got to do is figure out the signs. Now, this one doesn't have a middle term, so that's another tell on this one. That's another trick to watch for. When you see no middle term, and put some little dots here, and a negative sign in, on that last term, and they're both perfect squares, then you got yourself here something that's called the difference of two squares. And that's what this one is. And so these always kind of fall into a category. There's a little rule, and you can actually see that at the bottom. There's something squared minus something else squared. It's going to work out like that. That's the rule, okay? One of them is going to have a positive sign. One of them is going to have a negative sign. So all I have to do, put that right there. Checking the outer term, I got a 5x times 4 would be positive 20x. That's this one. And when I do inner times the inner, I'm sorry, that one should have been -5 times negative 5x times -4 would be -20x. Positive 4 times 5x is plus 20x. And see how those cancel each other? That's why there's no middle term there. So watch for when there's no middle term. You got to have a negative sign, because if these are different, then positive times a negative is going to give you a negative, and it's got to be perfect squares, unless you're going to go to square roots or something. This one had a rule too that I didn't mention. Don't really know why the b squared ran away down below. But here, We kind of fiddled with it and found the right answer here, but there is a rule that you can kind of follow if you want to do it that way too. When there's something times x and that whole thing is squared, like right here we had 5 squared x squared. There was a square root of that, right? And the last term was squared. And then the middle term is twice the first one times the second one. Remember when we did our outer, we got 10x and the inner was 10x. So we got twice the a times the b. If a is the square root of 5, 25x squared, and b is that square root of 4, then that's the rule down there. Maybe that's more work than it's worth. I don't know. Play with it, use the rule, whichever you like better. But that's a good trick too. All right. Here's a trick down at the bottom when you have cubes. And you can already see that there are some similarities between the perfect squares that we did in the last problem and the perfect cubes that we have before us here. So what I have to do is in the rule, I'm looking for something cubed. And sure enough, I've got something cubed. It's x. All right. So if you want to come in here and say I had something cubed, in this case, the a is equal to x. All right. Then on the last term, I need something cubed. And sure enough, 27 is 3 times 3 times 3, or 3 cubed. So that b is 3. And if you want to use the rule, then you can just come in here, now that we've got our a and our b figured out, and we could say a was x and b is 3. And then I need a squared. So that's going to be x squared plus or minus. Let's leave the signs out for right now. I'm going to come back and do those. I apologize. Oh dear, look at me. Doesn't want to do that, does it? I'll get it here. One more try. Come on. There you go. All right. And so I need to do 2 times a times b. Well, that would be 2. A was x and b is 3. And then I need b squared at the end. B is 3, so 3 squared would be 9. All right. And we straighten this out a little bit, but we do have to figure the signs. The way we do that is we look at the sign right here. It's positive. And whenever I have the positive, like I do on the top here, then I go across and I do the top one. When it's positive, I use the top one here. I use the top one here. And this is the same in both cases right there. So if I just put plus, plus, I'm sorry, right here, plus, minus, plus. I need a plus on this one. I need a minus right there and a plus right there. That will work. And I'd have an x plus 3 out front. I'd have an x squared. I'm going to simplify this down a little bit. 2 times 3 would be 6. So there's a negative 6x plus 9. Will it factor some more? Yes, it would actually. X plus 3. We'll leave that first term alone. And then here, I could break this into 2 binomials. And the factors of 9 are 3 and 3. The signs are alike, but they're negative. Okay. If I do that right there, then that's as far down as I can break that nut. And as far as I can simplify it, the only other thing I could do is I say, well, gee, I've got 2 of these x minus 3. So if you wanted to, and again, I don't know if this would help or move you in a direction you need to go, but it's perfectly legitimate to write it like that as well. Okay. There's one more here, dashing through this one. The first one is 2x that got cubed. So my A is the stuff that got cubed, 2x. And then 64 is 4 cubed. So B is equal to 4. And when I come in here, I want to do A and B. So that'd be a 2x and a 4. I'm looking at my signs now. I'm going to change colors here because I've kind of worn that purple out. I'm sick of looking at it. And I need to differentiate between all that marking at the bottom. I got a minus sign right here. So now I'm down here on the bottom, and I just want to ride the bottom train all the way along, right? So it's going to be minus, plus on the bottom here, plus, and the last one's always plus. Okay. So between A and B, I need a negative sign. And then I need, what do I need right here? I need A squared. A was 2x. So when I square that, I would get 4x squared. I need a positive sign. I need a 2 times A times B. That's going to be a 2 times a 2x is A. The B is 4 there. And then lastly, I need a B squared plus B squared. So B is 4, and 4 squared would be 16. And if I can clean that up any way I would want to, and that would be a 4x squared. 2 times 2 would be 4, times 4 would be 16x plus 16. Okay. Now, I forgot to do something there, didn't I? If I see it, I did not pull common factors out of this. And that's why right here, that has a common factor, and this has a common factor. And so really, if I had taken a moment and looked at this thing a little closer and said, gee, I could pull that 8 out and then have an x cubed minus 8. See how much simpler that would have been? Instead of all these big numbers, get that 8 out of there. As it is down here, that 2x minus 4, I could pull a 2 out of that. And then right here, I could pull, there's a common factor of 4 right there. And sure enough, when I take that 2 and that 4, that would give me the 8 right there. Now I've already got the, the rest of it broken down. I'd have to use the rule at the bottom for that stuff right there. But, make your numbers as small as you can and see if you can't save yourself some work as you go. All right. The more of these you do, the better you get at them, the more you see them. This one's kind of weird. It's got fractional exponents. I wouldn't do a whole lot of this to you, but it's possible one shows up. I've already got the problem all the way worked out. And you know what? It didn't even save it right. So some of this is right. I've changed it in PowerPoint here and it didn't go through. Looks good to there. Let's scribble out this line and this line, please and thank you. Sorry about that. Okay. So here's the problem we're trying to factor this time. And everything looks pretty good. You go, ooh, I've got an x plus 2 here and here. That is a common factor. And yes, indeed, you can pull that out because it's in both piles. All right. So they've done that here. They got that x plus 2 and they pulled it out. I'm using the brackets here just to say, oh, look, there's some stuff and I got to distribute. And the brackets, I got parentheses and parentheses. And so sometimes it's good to step up to the next level just to make it easier to say this and this go together. These guys go together, right? But with that fractional exponent, this is kind of a weird trick here. This one has negative 1/3 for the power. This one has 2/3 for the power. And we saw last time or time before that meant take the cube root, but invert it, that negative sign there. This one says take the cube root and then square it. So what you want to do is to factor out the smallest power of these things. And the choices here would be negative 1/3 versus 2/3. Well, the smallest one would be negative 1/3. So you can see right there, that's why they've got that negative 1/3 out there. I pulled out x plus 2 to the negative 1/3. And now I need to figure out what, right here, what can I multiply by x plus 2 to the negative 1/3 to get this whole thing right there. All right. Well, all of it came out except for the 3x. So just put the 3x there. And when you distribute, you'll be back where you started. All right. I did not pull a 4 out front over here. So I clearly need that 4. I did pull some x plus 2's out. Um, I need something here times this stuff so that when I multiply, when I distribute, it goes sing like that, I end up with 2/3. Now, thinking about my power rule, when I have something to a power multiplied by the same thing to a power, I have to add the exponents, right? So here's where the weirdness begins. Maybe it already began. X plus 2 to the -1/3 times x plus 2. Let's just write that much out. X plus 2 to the -1/3 times x plus 2. Yeah, there's a 4 in there, whatever. Here I've got two things that are the same base, different exponents. I got a -1/3 for that one. This one's really a +1 right there. I need to add those exponents. So this is really x plus 2 to the -1/3 plus 1. And because we're dealing with fractions here, I'm going to write that as a fraction, 3/3. And can you see that that does indeed -1/3 plus 3/3 would give me a +2/3, which is what I was looking for. Okay, so that one's kind of tricky right there, but it does work. Okay, I took all this stuff and copied it, so it didn't do anything here, but inside the parentheses, next up, we can distribute the 4 times the x and the 4 times the 2. That'll give us 4x and 8, and all this stuff that I typed it, I swear I did, but it didn't save it for some reason. We'll scribble that out even better. And then down below here, I've still got the x plus 2 raised to the -1/3 power. And then all this stuff inside the parentheses, I got a 3x and a 4x. So it'd be real nice to put that together to make 7x. Got the +8 hanging on the end. And that's as far as that one's going right there. Okay. That one's kind of weird, but it does work out. Again, if you have fractional exponents, factor out the smallest power of them and figure out what to do. Remember with your rules of exponents that in the product, sorry, I lost my, here it comes. The product rule for exponents, when I have x to the a times x to the b, you're multiplying, so I need to add the exponents. And that's what we did right there. That -1/3 plus 1, or 3/3, would give me 2/3, which is what I needed. All right, good luck with that one. Last one I have here is called factoring by grouping. I don't ever do it this way. I don't really like this method, but it works. And if you want to see it, here's how it goes. If this is the problem that we're beginning with right here, there's a little trick that you can do. And what you're essentially doing is you're taking this 5 and that 6 and multiplying and getting 30. And so you say, show me the factors of 30. And actually, -30 is what we want because of, here's a positive and there's a -6. So multiplying, you get a -30. Here's all the ways that I can multiply two numbers and get -30. 1 times -30, -1 times +30, 2 times -15. You get the idea here, right? So next up, what they're doing is they're saying, looking at this middle number, and we've kind of done a variation on this, but a 7. Can I add these and get a 7? Well, 1 plus a -30 would be -29. So this one just doesn't work. There's a +29, doesn't work. -13 is no good. +13 is no good. I got 2 left. If I use a 3 and a -10, that gives me a -7. But remember, I wanted the +7 right there. So that last one is what I want. And what we're going to do here is take that 7x and separate it into -3x plus 10x. You're using these numbers right here, and you're putting them here, and you're saying, yep, that's another way to write 7x minus 3x plus 10x. Okay. And then what you can do is kind of chop this thing in half right here. And you say, well, I got 5x squared minus 3x. That's right there. And I've got a 10x minus 6. I've got that over here. And I'm looking for common factors in this first one. And sure enough, there's an X in here and here. So I could pull that out front. When I multiply by something here, 5x times x would give me 5x squared. Negative 3 times 5 would be negative 3x squared. So we pulled a common factor out of this first binomial. We pull a common factor out of this one. There's a 2 in both of those. So we put the 2 out front. 2 times 5x would be 10x. 2 times negative 3 is negative 6. Okay. Now they both have a 5x minus 3 sitting there. That's a common factor. So they pulled it out front like that. And what would I need to multiply this by to get all that? Well, I didn't get the x and I didn't get the plus 2, so that goes over here. Okay. It's kind of written up there how you do it. That's factoring by grouping. It's kind of weird too, but it does work. And sometimes these things get big and nasty, and that might be a good way to go after it. Having lots of tools is a good trick. So there's another one. Well, that's what I got for today. Thanks for stopping by. And if you have any questions with these, you're welcome to bring them up in class. You also are welcome to write me an email or a text, and just like at any time, and we will figure it out. Thanks for stopping by.